Okay, hi guys. So thanks for coming to this Hackerspace. So my name is Yik Jin, and we'll be going through today's workshop will be about intro to PCB design, as you can see here. So a brief outline of how we are going to go.
Keep speaking.
Yeah. So okay. So a brief so briefly, how it's gonna go, right, is that we're gonna go through this intro to PCB design for like the first 1-ish hour. Then afterwards, it will be like free and easy session. So like you can like continue working on the PCB, or like if you have any questions regarding hackers or anything, you can just approach the Coreteam members lah. Okay, so yeah. So first thing first, prerequisites. Obviously, we would need a software to design your PCB, right? So the software we're using today is called KiCad. So the latest version is version 9 point something. So you can just go to this link on the slides to download. Yeah. So show of hands, who has already downloaded KiCad? Who has trouble downloading KiCad? Okay, so yeah, it's just your potato laptop. Okay, so you can either download and then like follow along as I go through the PCB design, or you can just listen along lah. Yeah, so we'll be going through we'll be making a basic PCB from scratch. So I'll be going through later. So firstly, why make a PCB, right? So PCB is a printed circuit board. So it's basically like a very compact form of circuit. So the benefits of it compared to a breadboard circuit, right? So if you're familiar with breadboard, it's like those like a white plastic thing with like holes where you can like prototype on. So like the reason why it's like better is because like firstly it's more compact because it doesn't have to be in breadboard size, like in a breadboard size footprint where like everything is like where each hole is like 2.54 millimeters apart. So that will cause all your components to be very big. Secondly, it's more durable and more vibration resistant. So if you shake it around, like, you know, your wires won't come loose, like something suddenly won't get disconnected, and then like you panic for like your project and be like, wait, it worked last night but today it doesn't work. Then you push down all the wires and you realize, oh, it's because one stray wire got disconnected somewhere. Yeah, so PCBs, you won't have that issue. So also it's more, so on that note, it's more reliable. So you also won't have issues like unintentional short circuits from loose wirings, like if you have two wires accidentally like touching each other like outside the breadboard or even inside. Sometimes like if you like stick it both like at a wrong angle, yeah. Or you can have like, or you might have incorrect wirings if you use breadboard. So you know, like if you make your circuit and then like it works and you take it out and then the next day you want to assemble it back, then sometimes you plug it to the wrong hole or whatever. So yeah, PCBs will like not have that issue. Yes, so and lastly, it's also more efficient because there's less parasitic capacitance, as you can see here. So meaning like, you know, when you like connect wire to wire on the breadboard, sometimes like there'll be more so there'll be more capacitances that you don't want, like as you connect the wires, because like there's like longer wire traces. Sometimes like the connections are not that secure, that kind of stuff. Yeah, and PCBs also allow for more complex layouts and more layered designs. So breadboard is just one layer, PCBs can have multiple layers. So you get a feel of what I mean by multiple layers later as we make our own PCB. So before you make a PCB, there are like 5 stages to this. So very briefly, it's just ideation. You think of what you want to do. Prototype is you take your breadboard and then you plug it into the breadboard to see your basic circuit whether it works or not, to see whether the idea can even like, you know, take shape or like, yeah. So thirdly is schematic. So you transfer your breadboard diagram, your working breadboard diagram, to schematics form. So that's like your circuit symbols and stuff that you are used to in, for example, like secondary school, O-level, that kind of stuff. Yeah, so fourth is layout. So you take your circuit, your schematic circuit, and then you translate it to how it will appear on the PCB board itself. And then you wire up on the PCB board as well. Lastly, you send it for fabrication, which means that you send your PCB to be made. So these are the 5 general steps, but because today we don't have the breadboard, right, so we just skip the second step. So usually, sometimes people also just skip the second step because like they don't have like the modules that are required for breadboard compared to like, you know, just straight up just have a small module on the PCB and then just wire up. Yeah, so we'll be doing ideation, schematic, layout, then fabrication. So like what I said, first step ideation is where you come up with features and requirements. So like, you know, both your functional requirements and non-functional requirements. Yeah. For today, we'll be just making a simple LED that light up when you connect to a USB port for power, and then there's a button. When you hold down the button, it will light up. When you release the button, the LED will disappear. So I know it sounds like a very simple circuit, but that's because today we are assuming like no prior knowledge of like electronics at all, and this is a very good stepping stone into like the world of like making your own PCB. Yeah. So if you want this set of slides, right? So if you're ahead or behind, you want this set of slides, you can see the links at the bottom. So the first thing on top is the slides link. The second link at the bottom is the final product of the PCB. So if you're stuck somewhere or you don't know what to do, you can refer to the project files. So yeah, this is the final product for today. You can see on the left here is the USB-C. Then there's a button for you to press. Then this D1 is the light. Yeah, so at the back it's just like some text. So you'll be learning how to do all this today. So yeah, like what I said, we're skipping prototyping, and then schematics. We'll be designing it directly in schematic circuit form. So with KiCad. Yeah, so KiCad is basically an EDA tool. So EDA stands for Electronic Design Automation. This is where you like design your PCB and your circuit. Yeah, so we are using KiCad because it's firstly feature rich and it's also free and open source software. So you can just download it for free without like having to pay. So like you can see some other like software here. For example, Altium Designer, past a certain complexity or past a certain point, right? Like you need to pay Altium for their software and for software license. Then Easy EDA is free for I think the basic version. Then there's a paid version of it as well. So KiCad is just completely free, which is why we'll be using it. And the industry is also like increasingly adopting KiCad as well. So after you download KiCad, right, this is what you will see. You open up KiCad and this is the main project view. Right now, you can see here there's no projects because we have not created any. And then on the right here, you have some buttons. So in general, right, the way to go about making a PC project is top to bottom. So you start with schematics, and then if you have some missing schematic symbols that you want to create, you can create with the symbol editor. Then after you're done with schematics, you can move on to PCB editor, where you'll be editing your PCB design. Then if let's say in the PCB design, you are like missing some component shapes on the PCB board because it's not pre-made, you can make it under footprint editor. Then finally, after you can export it all to Gerber file format. So this is your production file format that you send to your PCB manufacturer, and you can preview them in the Gerber viewer. Yeah, so you can see in general, right, you work from top down. Yeah, then the bottom here are all like miscellaneous tools. So to create a KiCad project, right? Okay, so you guys have the slides here. If you all want to look at the slides, you all can continue looking at it, but I'm just going to like show it to you. Let me close this project. So this is how you look like when you first start up KiCad, right? So to create a new project, you go File, New Project, or you can just go here, New Project. Then you can create a new project. Let's say I want to create it under HSP. Let's say I want to create a new project called USB LED. HSP for Hackerspace. So if you want, you can follow along. If you don't have the software, you can just look at what I'm doing. So I'll be creating a project and I'll be creating a new folder for that project, right? So I'll save it. And then you can see now my project has been created. So your open project will be shown on the left here, and these are all your project files. This view is pretty similar to like your Explorer view. So you know when you open your File Explorer, this is what you see. So it's pretty similar. So once you're here, right, the first thing you do is you open the schematic editor, because you'll be creating a circuit straight here. So you click on this, and then it will take a while to load, and you open up this screen over here. Okay, so once you are here, right, you can see that this is a piece of paper. It's a piece of paper where you can draw your schematic, and then down here you can see that there's this information section. So this is what we call a title block over here. So this describes your schematic information and things like your title, your date, the revision of the hardware that you are using, that kind of stuff. So to edit this title block over here, right, you can go top left over here. Can you see this paper icon with like you hover over it, you should say page settings. So you click on page settings, this screen should pop up. Yeah, so the page settings window should pop up, and then you'll be able to enter your information for your schematic. So this is considered good practice to populate this information. So I'll just do it very quickly here. If you want to, you can also follow along. So revision, let's say V1, title is like, let's say Intro to PCB Design, then your company, I'm from Hackers, so let me just put NUS Hackers. Then comment, let's just, you can put anything under comments. So I'm just gonna put Hackerspace. Then once I'm done, I will just press OK. And once you press OK, you should be able to see these populated like this over here. So this is the date that the date and then the title, then yeah, the organization, your other comments will appear here. Can so far, right? Okay. So like what I've mentioned just now, we're working on the schematic, right? So the first thing that you will need is basically your schematic components. So where do you get your schematic components? On the right over here, there's this button called Place Symbols, or you can press A on your keyboard. So you press this, you give it a while, you like load all the schematic symbols that's available to you, and then load the footprint libraries, and then after a while, it should pop up a window. This waiting will only be done for like the first, like you only need to wait for 30 seconds or so for like the first run. Then afterwards, it should be cached. So it's not that painful. Okay, so now you should see this window over here. So let's think of what we need. So for our USB LED circuit, right, what do we need? Definitely a USB connector, right? First of all, so let's search for USB. So you can see here under the section called connector, there's a bunch of USB stuff. So there's USB-C plug, blah, 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 whatever. So since USB-C is the standard, like it's going to be standardized everywhere, so let's just use USB to keep up with the times. So USB-C, then you can see here there are some variations of the different USB-C. If you click around, you can see like on the right here will be the schematic component that is under preview. So you can see there's 14P, 16P, 6P. So P stands for pins. Pins meaning like the number of exposed pins for you to connect to on the pad, on the PCB. So in our case, we just need 6P because we only need power. So USB, they provide data as well, right? We don't need the data because we're not connecting it to any like chips or like any microcontrollers or whatever. So we just stick with power only. So there's this 6-pin version which looks good to me. You can see over here there's V-bus, which is your voltage, CC1 and CC2, which is your sensing pins. I'll go more in depth later. Then there's ground and there's shield. So this looks good. So I will just press OK. And then you can see when I press OK, right, the symbol will be like on my mouse cursor but not placed yet. So if you move around your mouse cursor, your symbol will be going together with your mouse cursor. So you can press anywhere to place it down. Then your keycap will automatically continue to like select that component for you to place down your more. So if you don't need it anymore, right, you can just press escape on the keyboard. Then it will cancel out of that component. So now you can see here to zoom, right, all you need to do is to mouse wheel up. Mouse wheel up will zoom, mouse wheel down will zoom out. Then you right click anywhere on the sheet and then you can move around the sheet. So zoom with mouse wheel up and then you can see over here we have all the pins. Yeah?
Question for you.
Yes.
Do you not select the object?
Press escape on the keyboard.
Okay.
Yeah. Yeah, so when you press escape on the keyboard, right, you'll see that the mouse cursor, under your mouse cursor, there's still the add symbol button that's still active. Or you can, over on the right, you can see this blue highlight over here. The place symbol is still active. So if you left click on it again, left click anywhere on the sheet again with this active, right, you'll bring up the same window that you've seen just now for you to select another symbol, another component, yeah? So let's think, what other components do we need? We definitely need an LED, right? So let's search for LED. So when you search for LED, there's a whole bunch of components over here. You can see LED, ABGR, A blah 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 blah, whatever. But all these are all like multi-color RGB. So you can see there's like 4 pins because there's like one for RGB, and then one common pin. So right now, for simplicity's sake, we'll just go with the normal LED, so just one color. So one cathode, one anode. So once we are happy with this symbol, right, we double click on it, and then same thing, it will like hover over our cursor until we press down. So let's say I just click anywhere, and then yeah, so it's placed down there. So I don't need the second one, so I just press escape. So yeah, finally we'll add another component called button. But buttons, right, are called switches because technically buttons are momentary switch. When you press down, it closes the switch. When you lift up your finger, it opens the switch again. So they are called switches in KiCad. So when you type SW for switch, right, then you come out all these different types of switch. So what we want, right, is a push switch because it closes only when you push. So it's called push switch, so you choose SW_push. Yeah, if you're not sure which component to use, again, you can just click through and then you can see like the schematic symbol, see which one looks right. Obviously, this one looks right because it's just 2 pins and then a button they'll push down. So we select this, we press OK, paste it down again, escape.
How do you pull out the schematics in the listing again?
Press A, or on the right here, can you see like there's the op-amp symbol, the triangle symbol.
Where's the triangles? Right. Oh, okay, the right side is the triangles.
Can I move please?
Can. Okay, so now we have 3 elements here, right? So we can start happily piecing them together. So how do we piece them together? We need to wire them up together, right? So to wire them up, we need to first see where the power source is. So V-bus is the power source. So for USB standards, right, USB provides 5 volts. So V-bus will be around 5 volts. So this is your 5 volts. You want to link it to the button, then you want to link it to the LED, then you want to link it to ground. Make sense? Can, right? So to change to start wiring things up, you press escape to like quit out of the symbol, the place symbols mode. Can you see like on the right here, the button is still blue, the place symbol button is still blue. So that means this mode is still active. I don't want that. So I either press back this select items mode or I escape again. So I escape again. Now my mouse cursor is just a normal mouse cursor. So now I can press elements, I can drag them around, that kind of stuff. So let's place the button beside the V-bus and then the LED beside the button because that's how your wiring is going to look like. Make sense so far? Okay, so you see the LED is like, if you're familiar with electronics, right, LED, your current should be coming from this end to this end because the triangle points this way. Your LED current comes from the right to the left here because the triangle is pointing this way. So current goes from right to left, not left to right. Can, right? So you realize our voltage, our current source is coming from here, from the left, which means you need to rotate this, right? So how do you rotate this element? You press R for rotate. So you press once, you rotate 90 degrees. You press another time, you rotate another 90 degrees. So now it's pointing in the correct direction. Can, right?
How do you rotate it?
Press R to rotate. Yes. So now it's pointing in the right direction and then I can start wiring things up. To wire things up, I have 2 ways to get to that mode. I can either, on the right here, see this thin blue diagonal line that says draw wires when you hover over it. You can press this or you can press W. Or you can just hover over this circle right here. And then that draw wire mode should be prompted. So again, it's either this, draw wires, you click on it, or you press W, or you just hover over the end of this pin. And then you can click on it, and then you draw a wire to your button component. So you click on the V-bus pin, and then you drag it to the one end of the button. And then when you click on it, the wire will be connected. Can, right? Yes.
If I literally just place it like front and door is like off each other, is that like actually connected or is it just a visually like?
if you on top of each other, as in like this,
Yeah.
yes, it's connected.
Oh, okay.
Because you know it's connected because this bubble disappears.
Oh.
This bubble is the unconnected bubble. So when you connect it, right, you see, if you connect it, right, and then you drag this component out after you connect it, right, you drag this component out after connect it, the wire will be there also. Yeah, so once you're done with that, right, you connect the button and the LED together also. And then once you're done with that, you need to connect these to ground. So you have two choices to connect to ground. One is obviously you take this and then connect it straight to ground, right? Like that, something like that, right?
Yeah. How do you choose where to make the bend?
So for bands, right, it will auto place the band unless you click halfway, like you see, right, once you're here, right, you want to place the band, like let's say here, you press it once and then you can continue. Like click once. So click once again, then you come here, click once again, click once again, click once again, click once. Yeah. Yeah, so as I was saying, right, one way is like to connect to ground, you just connect like that. Which is okay, but in a big schematic, right, it will look very complicated because your wires will be flying everywhere all over the place. Especially for ground, because ground is it's a common connection, right? So the better way is to use what we call a power symbol. So power symbols are things like your power source and your ground symbols. Yeah. So where you can access your power symbols on the right here, there's this right under the place symbols, right? There's this ground sign thing here that says when you hover over it, it should say place power symbols. Or you can press P for power. So click on it. This screen should come up. It should look very similar to the place symbols, except that instead of symbols, right, it's all your power stuff. So you can search for GND for ground. So you should see ground 1, ground 2, ground 3, blah blah blah, whatever. We just need normal ground. The different grounds are there for you to connect to, well, different kinds of ground. Yeah. So you just double click on this or press OK, and then this again, like your place symbols, this one will become attached to your cursor. So your ground, let me place one here, one copy here, right next to the LED, because I'm going to connect the LED to ground. Then once I'm done, right, I still have a copy of ground attached to my cursor, and I want my ground to also be connected to the USB ground and the USB shield. You have to place multiple, because you see, right, ground USB here needs a ground also. So in your wire, right, your USB wire, right, there's a ground connection.
I understand that, but like, how does like whoever who's receiving this schematic interpret? It's like a teleport.
Yes, it's like a teleport. So basically, all ground symbols teleport to one another. So there's an invisible wire connecting them.
Oh, so but then like, why do I then like the USB schematic already labeled ground, then I still have to place it like ground?
No, their label ground is called, the pin is called ground. But is it ground? Not yet, until you connect ground. Yeah.
Will you ever connect it to anything else?
Yes. For example, if let's say your ground, you want it to be like what was it called? EMF safe, right? Like ESD safe, sorry. Then you can connect like some like capacitor or resistor to it, then to ground.
Oh.
Yeah. So that kind of connection is common for shield connection, but for simplicity, we're just gonna be like ground, that's it. Yeah. So you put two other grounds here, or you can put one ground and then connect both to the same ground. Like both the shield and the ground to that same ground. Up to you. So once I'm happy with all my ground placements, then I don't need the hovering ground over my cursor. I can quit out of the ground mode, and then I quit out of the place power symbol mode by pressing escape again. So press escape twice. So I should be back in place like normal selection mode. You can see your mode again on the right hand side. You can see which mode is active on the right hand side. Can, right? So afterwards, I just wire everything up. So LED to ground, then afterwards shield to ground, then ground to ground. Yeah, so if everything is connected correctly, right, you should see the hollow circle disappear at the end of the pins. If let's say you mess up your wiring, you can just press on the wire, click on the green wire, and then press escape on your keyboard to like remove the wire. Okay. Can so far everyone got this schematic? Okay. Great. So now we will be connecting the CC pins. So the CC pins, right, are what we call sensing pins in USB. So there's CC1 and CC2. Why? Because a USB-C, if you know how USB-C looks like, it's like this, right? It's like the round USB thing where you can connect both directions. So how it connects both directions is that there is like each side of the USB, right, there's like the same set of pins. So let me Google the image for you. Let me see if I can find, yes, this one. So you see, right, this is how a USB-C connector looks like. So this is the plug itself. The bottom is the connector, like for example the one on your computer board. So you can see right there, there's like one row of pins on top, one row of pins at the bottom. So the pins on top and the pins on the bottom are mirrored. You can see it starts ground, RX2 plus, RX2 minus, then here's ground, RX1 plus, RX1 minus. Yeah, so they are mirrored. So this is how they ensure that whichever way you plug in, right, like you will still be able to use the USB. But with this benefit comes the problem of the computers having to figure out which direction your USB is plugged in, right? Like if it's up or if it's down. So your computer needs a way to know that so that it knows like to transfer, when you transfer data, whether to use RX1 or RX2. So how they do this is by the CC pins. So CC pins basically, right, they sense, like for example, when you connect one direction, only CC1 will be connected, but CC2 will be left on, not connected. When you connect the other direction, CC2 will be connected, but CC1 is not connected. Makes sense so far? Makes sense, right? So that's why in order to aid the computer to be able to figure out which direction your USB is connected, right, you need two resistors, one for each CC pin. Yes, so to add a resistor first, right? To add a resistor, again, you go into place symbols, which is A, click on it, and then you want a resistor, right? So a resistor, you don't have to type resistor, just type R, it will come up. Because the element itself is just called R for resistor. Yeah, so once you find that symbol, you double click it. Then I want 2 copies of the resistor here. So I place 2 copies and then I escape out of placement mode and then I escape again to go back to item select mode. So now I have R1 and R2 here. The next thing we need to do is to set the resistors values. So the resistor values for CC pins, right, for USB is fixed. So the resistor value that you need is 5.1 kilo ohms. Like it's fixed. Like if you want to know why, just it's part of the specification of USB. USB-C 2 or 3, I cannot remember. But yeah, it's part of the specification. So in order to indicate the value, right, you need to go under values here. And you see the R here, you change it to 5K1. Why 5K1? Because it's 5.1 kilo ohms. And some engineers, they don't really like to do this 5.1K because the dot, right, is very small. So sometimes when you print it out, or if you are like, your eyes blurry or whatever, then you don't see the dot, right, people might read this as 51K. So to get rid of that problem, they replace the dot with the SI prefix. So 5.1K becomes 5K1. Then you can just omit the ohms because it's implied it's a resistor. There's only ohms. Yeah, so you click OK, then you should be able to see here 5K1. Do the same for R2. So 5K1. Okay. So now you have your two resistors of 5.1 kilo ohms, right? Then you need to connect each CC pin to each resistor. So you can very easily just click the bubble, connect. Then the ends here, right, needs to connect to ground. So what you can do, right, you already have ground here, right? Just highlight, Control C, Control V. Then you don't want to draw the wire, right? You want to save some step, right? Just connect straight to this component. And then you just drag it out. Then the wire will be drawn. Then this one, you just connect here, connect. So we have done a lot of work so far, right? So please make sure to save your work. How to save? Top left corner, see the save icon, just click save or Control S. Yeah. Remember to always save. KiCad doesn't crash that frequently, but if it crashes, yeah, you don't want to be crying. So.
It's not like when I added like the first component, KiCad instantly crashed on me.
Oh, that's tragic.
Yeah, I had to like, that's why I just kept saving after I added every component.
Yes, yeah, please always keep saving your project. Okay, so now you should have this schematic right here. Are we done with the schematic? No, we are not. No, we are not done. This is a very common mistake to make. You see this LED? You see these 5 volts? There's no current limiting resistor. So if you connect this straight, you send it to fabrication, and then you receive the PCB, your LED will instantly burn out. Yeah, because it can't receive like that much current. It will like blow. So this means I need a current limiting resistor. So very easy. You can either place a new resistor or you can just Control D to duplicate. Yeah, so Control D is shortcut for Control C, Control V. So you can see now it attaches to my cursor. So I want this to be between the button and the LED, right? So I place it somewhere here first. I place it somewhere here, and then I need to start shifting the LED and the ground out of the way, right? So that I can place this. So I can highlight this. So in KiCad, there are 2 ways of highlighting things. One is you drag from left to right. So this means your whatever element, right, is inside. Whatever element is fully inside your box that you draw, right, will be selected. You can see here my LED is partially selected, my ground is fully selected, so it will only select ground. If you draw from right to left, everything that's touching the box at all will be selected. So if you do this, right, same as just now, right, LED partially selected, ground fully selected, you release, right, LED will be selected. These are just, yeah, shortcuts.
How do you tell the difference? Which extension you are dragging?
You can, okay, so when you start dragging, right, can you see the icon under my cursor? So this is a fully enclosed icon. Then this is the partially enclosed.
Just a dot.
Yes. Yes, so I want to select the LED and the ground and move it out of the way. So that I can start attaching this, right? But it's in the wrong orientation. So how do I rotate? Yeah. I press R, and then another shortcut if you want to insert things in between, right? Don't need to remove the wire, just place it on top.
Wow.
Yeah. So now I have the resistor in between the push button and the LED. So I can clean it up a bit if you like. If the spacing bothers you a bit, you can clean it up, then clean it up. This one you see is a bit wonky, you can highlight it, clean it up. So now your final task is to figure out what this resistor value is, right? So anyone familiar with Ohm's law? You know your O levels, V equals IR, then P equals IV kind of thing. Can, right? So theoretically, you can calculate the current limiting resistor value by using that bunch of formulas. But I am lazy, so I can just go Google search current limiting resistor value calculator. Sorry, I'm typing with one finger because I'm holding the mic. Then you see the first result. Yeah, I'm just gonna press it. Then you see this. Then you can see, right, you will need power supply voltage. Then it needs like some details about your LED, right? But you have not chosen an LED. So this is where I will introduce to you component selection. So how do you do component selection? What is component selection? Basically, you have schematic symbols here, but your end product will be a final physical PCB, right, with things on it. So what things are you going to put on it? Like you can say I want a resistor, but what kind of resistor, what size of resistor, what values of resistor, you know, all that kind of stuff. So you need to choose a component to go with your symbol. So usually, right, for simplicity's sake, right, I'm going to just choose the components from the PCB manufacturer themselves, because for PCB manufacturers, right, most of them have an option for you to assemble the components like they can assemble the components on your PCB while they're manufacturing your PCB together at the same time. So if you use their components, right, you will basically save time because when it comes, you don't have to solder it yourself. Yeah. Your other options are like you self-source. Like for example, you go Shopee, you go Taobao, and then you find the component you want. Then afterwards you solder it yourself when the box comes. Yeah. So again, because I'm lazy, so for this workshop we'll be using a PCB manufacturer called GLC PCB. So GLC PCB is this company over here. It's a overseas, Hong Kong company, I think. Shenzhen, Hong Kong, somewhere there. Yeah, it's a company from there. Then they'll like manufacture it for pretty cheap, and then they'll ship it to you. So over here, right, if you go to glcpcb.com, right, /parts. So this is where they list all their component parts for you to choose your components. So for example, I want to choose what do I want to choose again? I want to choose my LED, right? So to choose an LED, all I have to do is to either come here, the search box, you type LED, or you can just like scroll through their whole list of catalogs, and LEDs under diodes, I think. No, not diodes. Optoelectronics. Yeah, optoelectronics. So it's under LED indication discrete. So this is the LED. All the LED stuff. Yeah, so when you click on the LED indication discrete, right, you bring you to this page where they list down all of their like LEDs that they have available, from like single color, multi-colors, like whatever size you want, whatever shape you want, yeah. So you can see there's like 49K results. So how do you start filtering down? Cause I'm a broke student, so how I filter down is usually by price. So usually the cheapest, the parts that don't cost extra for them to put on the PCB board for you, right, are called basic parts. So I want basic parts. Instantly down to 6. I also want datasheet and photo because I kind of want to see how the product looks like, you know, before I choose a product. I chose it and then I press apply. Then I filter by my favorite category called price. You can see here, now I press twice, right? So now this up arrow selected means it's sorted by ascending order. Ascending order, wow, so cheap. One LED for not even half a cent. Not bad, not bad. So let me click on this. Then you expand, you can see like all the details about the component you selected. In this case, right, what I care about is basically the package size. See whether if it's okay with you. So package size means like the size of the components. Yeah, so if you can search online for like the list of package sizes, or if you have time later, you can come up to me. I have like this very handy ruler with all the package sizes if you want to take a look at it. It's pretty small. 0603 is like small. It's like if you drop on the floor, you can't find it anymore, kind of small. Yeah, so you can search online for like the full list of like sizes that you want, but usually 0603, 0402, 0805 are like the more common ones. It's usually around that size. So like, yeah, so this is all the details. You want to see more, you can press here. Then you bring you to the actual product page instead of like a flyover. Yeah?
Does the number have a meaning?
Which number?
Like the 0603, does it mean like 6 mm or 0.6
This?
mm or something?
This or this?
Like the package size number.
Yes, it's in inches, I think.
Oh.
Actually, I'm not sure. Wait, let me. You know what?
0.0.
Time to search. Let me Google with you. Resistor size. SMD. SMD because the kind of resistor we want to use is like just on the board, soldered on the board with no holes. So those are called SMD.
It's in inches,
Yeah, it's in inches. So you can see like your 0603, right, just now that we have was basically 0.06 inches by 0.03 inches. Yeah, so one very important thing that I want to point out, right, when you are browsing for components is you should always look at the datasheet. Datasheet for GRC PCB available here, just click on it, you bring you up a new tab and then you like show you the stuff. It is very important to look at the datasheet because on the surface it might look like your component works, but actually if you read the datasheet, maybe like there's a current limit or like there's like some weird limit that's stated in the datasheet that will like not work on your circuit or on your PCB board. So it's very important that for every component that you select, you always look at the datasheet. And if you're lucky like we are, the datasheet is in Chinese. But it's okay because we have graphs and images are universal. So you see this, right? You ask me what is this, right? I don't know. I can only tell you this is current, this is current, this is current, this is voltage. Yeah. So let's look at the image. You can see relative luminosity, which means how bright the LED is, right? For example, so I want 100%, so the standard fault current is 20 milliamps. So very easy, I come here, 20 milliamps, standard current reading. What else do they want? Voltage drop. How do I find out the voltage drop? At 20 milliamps, the voltage drop is about 2.0 volts. So I change this to 2.0. My power supply is from the USB. USB is 5 volts. I have one LED. Right. Then I click on it. Ta-da! My current my resistor value should be 150 ohms. You want to know why? You want to know how? You do the math yourself. Yeah, it's ohms law, basically. Yes, so 150, right? So I go over here, double click on it. 150. Usually, right, for values without a prefix, an SI prefix, right, you don't type ohms for resistors. You type R. Why R? Because 1 ohms, that symbol, is not ASCII. So sometimes it might cause problems. 2, it might print weird on the printer. 3, I don't know, you can just use R because R is for resistor. And it's more simpler to look at. Less issues. Yeah. Yeah, so these are like conventions. It's not I come up with one, it's conventions. Yeah. So 150R, I press OK. Ta-da. Then, remember, back here, I decided that this was okay, right? This is the product that I want. So in order to take note of the products that I want, right, I can actually make use of something called the symbol fields. Over here, symbol fields. It looks like an Excel table. Click on it. It opens up to what looks like an Excel table also. Yeah, so very easily, I can just create a new column. So I can choose LCSC part number. I choose this field name because that column will be called LCSC part number because we'll be using an extension later for us to generate all the parts. And they look for this column name. So I type LCSC part hashtag. Yeah. Then I press OK. Then you'll be at the end here. And it's all empty. So what this is, right, is basically you just copy this because this is the part identifier. Yeah, so you just right click, copy. This is a LED, right? So LED is this one. Come here, paste, apply. And also, you see this footprint? So what footprint is basically like the thing that you put on the PCB, the shape on the PCB. So obviously, if you want to make a PCB, you need a shape for it. So very simply, you just go here, click on the library icon. Then you can see a full list of libraries here. But if you want it to be simpler, right, you can just okay, quit out of this. You can double click on the LED as well. You can see the footprint here also has a library symbol. Yeah, so you can access it both ways. The good thing about accessing it this way rather than the symbol, the Excel table view, right, is that it filters for you. So you can see now, suddenly like there's not a lot of stuff here. So I want an SMD thing, which is basically no holes, right? It's just all completely on one surface of a board. So that's called SMD, surface mount. Then my size just now, what did I say? What did I see was 0603, right? Yeah. So you can see there's two 0603 sizes over here. This is the regular 0603 size. This is the hand solder version, which is just longer on both ends. The pads are longer so that you can hand solder easier. I don't want pin for myself, so I want to hand solder easier, so I choose this. When I double click on it to choose it, it will fill up over here. It will populate the field. Then when I'm done, I just press OK. Then I save. So basically, you do the same thing for your other components. So my buttons, my switch buttons, right? So what do I want? I want to look for buttons. I go all components. It's under switch, I think. Switch. Tactile switches, yeah. It's under tactile switch. Then I do my thing again. I do datasheet. I want datasheet, I want photo. I just want basic parts. Then you wait for it to load everything. Should say 2 results. Then I'll be like, okay, let me see the 2 results. I press apply. It's like, oh, look, there's this button. Okay, so I've looked it up beforehand. Because of time, I won't be opening out the datasheet and walking through again. But I've looked it up beforehand. This works.
This is the one on the Hack&Roll then.
Yes.
It looks the same.
Yes. So very easily, I just copy this part number, and then I paste it here, the FCSC part number. So whatever you added in the table just now will also show up when you double click on the symbol. So remember, I get to this view by double clicking on this button. So there will be this part number, I paste it. So now that I found the part, right, now I know how it look like on the PCB itself. So now I choose a footprint. Click on the library icon. The footprint itself, it's a, what button is this? It's a XKB connect. It's by XKB connection, right? So if I want to search for it, I can go XKB. You come up this. This matches XKB TS1187A matches with the button that we have over here. You can see, right? So I double click on it. Yeah.
How do you know the orientation of the button? Like,
You will figure out the orientation later, because that's when you lay out the PCB. Now the orientation doesn't matter.
okay.
Now it's just the pins that matter, the way you connect the pins that matter. So I'm done with this, I press OK. Now I'm left with resistors, right? And I guess the USB. Yeah, so the resistor, I can just take this. Let me search resistor. Resistors are under a category called resistors. LMNOPQR. Okay, there we go. Surface mount. I want a surface mount resistor. So it's chip resistor, surface mount. Again, I want basic datasheet, photo. For resistors, the value matters. I mean, it makes sense, right? The value matters for resistors. So you can see that there are a bunch of filtering columns over here that GLC has provided us with. So I can very easily just type in the resistance. What do I want? I want, let's do like R1 first. R1 and R2. R1 and R2 is 5K1, right? Which is 5.1 kilo ohms, right? See this drop down. I can select this drop down. I choose kilo ohms. Kilo ohms here. Then I type 5.1. 5.1. Immediately down to 3. So I click apply because I just want 5.1 kilo ohms. Then you can see, right, there are 3 different results. The only okay, one of the main differences, right, between all these are the sizes. This is 0402 size. This is 0603. This is 0805. Normally, if I were to buy it for myself, I will buy 0805 because my fingers are fat. So I kind of don't want to lose it, and I kind of want to have a good life soldering. But because I am a broke student right now, so let's just go for 0402, which is the cheapest. You can see it costs less than a fraction of a cent. Effectively free. So yes, let's just choose this, copy this. No, this is on 5.1, then paste it under the parts here. Footprint, again, now that we know what component we want, it is a 0402 resistor, right? So I just filter 0402. It'll come up. One very important thing for resistors is that there's imperial units and there's metric units. Can you see this is 0402, 1005 metric. So metric is 1005. Imperial is 0402. This one, metric 0402 is imperial 01005. Different side. So when you say 0402, right, you might mean either imperial 0402, in which case is this size, or metric 0402, or in which case is this size. In resistors, we usually use imperial. When people say 0402, they usually mean imperial, unless otherwise stated. So let's just go with this. Again, I'm going with hand solder because I don't want more work for myself. Then I press OK. Then I do the same for R2 because it is basically the same thing. It's the same resistor. So I just 0402, then OK. Then I save. Can so far? Can, right?
Can you give me the part number again? I tried searching, but I only got 2 results. I didn't get
C25905. You search it here, right? It should immediately come up.
259.
Yeah, so now we are done with these two resistors. There's one resistor left, the 150 ohm resistor. Scroll back up, clear this. Very important, you need to clear this first. You don't clear this, you select both 5.1 and whatever you are selecting next. You clear it, you change this back to normal ohms. No prefix. Ohms. And then you choose 150 because you want 150 ohms. 150 ohms, then you'll be like, where is it? Give me a moment. 150, apply. You can see here now we have like two results being this and this. So let's just go with 0603, this part number, because it's cheaper and smaller. So I do the same thing, nothing new, just blah 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 blah. This is what size? This is now 0603. So it's no longer 0402, it's 0603. So I choose this, the hand solder version. Can, right? This should be pretty familiar to you already because it's just literally repeating the same things for all the parts. So save it. One last part that we haven't chosen is this USB receptacle, right? So this USB receptacle, very same thing also, just go back, scroll up, go to all components, and then you can see where is it? USB is under connectors, I think. Connectors, USB connectors. Yeah, so under USB connectors, you click on it, you come to here. Unfortunately for USB connectors, there are no basic parts. You can see when I hover over it, there's a no entry icon. So it's okay, I want data sheet, I want photo, then I want USB Type C. Apply. Then you can see these are all the results, and then you again I'll sort by price. Sort. Yes, so you can see these are the these are the results sorted by price. They are all Type C connectors. Which Type C connector to choose? I was going to choose this, but then I saw that there are two parts to it. Like you can see there's the metal housing and then the black housing thing. I couldn't figure out what the black housing was, so I skip. To this. This looks okay, I think. Let me click on this. When you click on it, I can see there are a bunch of pictures here, right? So usually the pictures are top view, bottom view. Looks okay. Yeah, okay, so this looks okay, right? So this looks kind of like the connector that we're looking for, right? So let's just take this, copy this, and then use it for my USB connector over here. Now footprint, if I click on the footprint, right, you can see that there are actually a bunch of footprints. So which one works, right? I don't know, so I need to click on the datasheet to download the datasheet to see. Wow, what is this? This, so you can see usually a datasheet shows you a lot of the mechanical measurements of the component. So over here, there's a recommended PCB layout. Over here. So the recommended PCB layout, blah blah blah. You should check all these like to this, to the PCB layout that you're going to choose. So like this and this and this should match. So how you match is basically you take, when you hover over here, there should be a ruler. Click on it, you see, you can measure things. You click on it again, you fix it. Keep clicking on things, yes, very cool. So you measure and then you will pick the one that suits your need most. But because of time constraints, I am not going to bother with that. I am just going to use this. So this is a generic kind of footprint. So usually if you want specific footprints, you see this is pretty specific, right? What you will do is basically you will create your own scheme. You will create your own footprint. So this is called footprint. The shape is called footprint. How you create your own footprint? I'm not teaching today. You can just learn yourself on YouTube. Yes, but it's pretty easy. It's just drawing shapes, honestly. So I'll pick this. Double click on it to choose it. Press OK. So one final thing before you're done with your schematics is that you need to verify it. So how do you verify it? You see this button, electrical rules checker. Click on it. You bring up this window with nothing yet because you haven't run the electrical rules checker. So what this does is basically it checks for violations. Violations meaning like electrical violations, like if you connect you shorted two pins together, or like you connect like a bunch of very weird things together, then that violates like some kind of like rules, that violates some kind of like things that you're probably not supposed to do, then you'll show here and warn you. I run it. You can see there's only one violation, which is power pin not driven by any output power pins. So this is a very common error in KiCad, because what it means is basically an input pin, right, it's not connected to an output pin. It makes sense, right? An input pin should have an output pin so that there's power to it, right? But if you think about it, right, a ground is basically an input pin because your power from whatever power source will go to ground. So your ground is an input pin, right? But there's nothing driving the input pin, which is ground, because you usually don't connect any output power straight to ground. So to solve this problem, right, usually in KiCad, we just go power symbol, then we put you search PWR, there should be a power flag. So this is power symbol again, press P, or you press the power symbol on the right, then you choose power flag. Press R to rotate. R. Then you press, you click here. Why I place it there? Because this is where the ground is. So by placing it near where the ground pin is, I'm symbolically saying that this is the source of the ground. So I can easily see and it makes sense to me. So this is just this is not a physical thing in your circuit. This power flag is just a schema to tell KiCad that this is a test. This is a output pin to bypass the error. So again, you run your ERC, you delete all markers, run again. Should be clear now. You should always make sure your ERC is as clear as possible before you move on to PCB, or else without a working schematic, your PCB is trash also. Yeah, and PCB is once you send it for printing, you cannot rewire the PCB. Okay, so at this point, it should be pretty good to go for schematics. Can? Great, so now let's move on to the PCB design, which is the fun part, because it's somewhat like art. So, how to go to PCB editor? One is you double click on this green. Number 2, you click on this PCB editor. Number 3, if you're in schematic, there's this green board here. All 3 ways lead to the same place. So I click on it, give it a while, it will come out with this. So again, same things, you can like go to this page settings, you can fill in your things, blah 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 blah. I'm just not going to bother with it because of time constraints. Again, your save button is top left button here. So, but on the right here, you have a whole new set of interfaces, right? That you are probably not very familiar with. So I'm going to go through them after I walk through this slide. So we're done with schematic and component part selection, right? So now we want to do PCB layout in PCB editor. But what goes in a PCB? You need to understand this before you design a PCB, because or else you don't know the different technical terms that they are using. Very simply, a PCB might have a single layer of copper, multiple layers of copper. Most commonly they are like either double-sided or with 4 layers or what, yeah. But something as complex as a computer motherboard may have up to like 32 layers, for example. Yeah. So right now we will be focusing on double-sided PCBs. So basically, copper layer on top, copper layer on bottom, substrate at the middle. Substrate, think of it as a non-conducting material that separates the two copper. That's it. Then on each surface of the copper, right, this is your PCB, right? So there are multiple terminologies as well. So substrate is this. So on top of the substrate, there's a color layer. The color layer is called solder mask. So in this case, the solder mask color is purple. On top of the solder mask, you can have text. In this case, it's white color. You can have multiple colors for it as well. So this text, right, this layer of text and stuff is called silk screen. Then also you have like your things like your pads, right? So your copper, you have the copper layer, but now that it's covered by the solder mask, right, you must expose some copper so that you have like some pads for you to put your component pins, and then you can, so that your pins can like touch the copper and the trace inside, right? Makes sense, right? So you can see here, this is the copper layer. Copper layer, you need to open a hole in the solder mask. So you need to open a hole in the solder mask to expose your copper. Then, where is it? Yeah, then this is the copper layer, and usually each of these things are what we call pads. So like each pin is what we call pads on the PCB board itself. Then the wires are called trays. And since there are multiple layers to this, right, can you see I sometimes need a way to connect the top layer to bottom layer, or like the top layer to layer N, or whatever. So the things that connect between these two layers, right, or multiple layers, are what we call vias. So via is basically just a circular thing. On a physical board, it looks like a circular hole, but it's not lah. It's a hole with like metal tube connector kind of thing. Okay, can so far, right? Okay, then we'll be going to set up this PCB board. So over on the left here, can you see there's this board setup, the green board button, board setup. Click on it, and then you can see that these are basically, on the first page, right, is the board editor layer. These are basically the layers that you want to use. Remember, the layers are things like, remember your silk screen, your mask, that kind of stuff. So if you don't know what this is, there's a bit of description on the right, or if you hover over the checkbox, it should have a bit of description as well. So we are going to remove adhesive. We're just going to remove adhesive. Adhesive. So F dot something means front layer. F for front, B for back. So B dot something means back layer, means the second layer. We're just going to remove the adhesive because we don't need the adhesive. We don't need the fab as well. Fab is fabrication. So fabrication means that it's just for manufacturing purposes. So most of the times it just contain things like comments. Paste we need because if you want the PCB manufacturer to manufacture the board, right, and place the components on it, the components need to stick to the pad, right? So how they stick to the pad is they use the paste. So the paste is required if you want to ask the PCB manufacturer to put the components. Silk screen again is the white text. Mask again is the color, the board color. FCU, BCU is front copper and back copper, meaning the copper traces, meaning your wires. So you can see you can choose a type here. So usually, right, you will have a signal plane and then a power plane. Signal meaning like your data, all your wires, your data, that kind of stuff. Power plane meaning like just like predominantly like let's say predominantly like 5-volt plane. Like the plane is mostly just 5 volts or like mostly just ground. Yeah. Usually for 2-layer PCBs, right, the top layer will be signal, the bottom layer will be power plane of ground. So again, you'll be mirrored. Your back layers will be mirrored. So back copper, back mask, back silk screen, back paste, blah 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 blah. This one, user equal 1 no need, equal 2 no need, comments no need, drawings no need, because these are all just user defined layers, meaning you can use it for your own purposes. User 1 again, no need, no need, no need, no need. So when you deselect all these things and you press OK, right, you can see your stuff here suddenly becomes a lot less, and it's a lot easier to like a lot less overwhelming. Save it, and then we still need to continue editing some stuff. So once you're done, you go physical stack up. You can see this is where you choose the number of layers you have. I want 2 layers. The dielectric is the substrate. Where is it? It's the substrate here. So the dielectric, you just choose FR4 is the material. Usually the normal boards are FR4 boards, like the most common material. You can pick your color here to show in the 3D viewer later. So let me just pick FR4 natural, and then the board, if I want to go with a generic like green PCB with like white text, this is how I do it. Then you do the same for bottom, green and white. Can, right? So the material is FR4, the PCB is green with white text. Okay? Then afterwards, board finish, don't have to touch. This one, don't have to touch. Don't have to touch. Okay, so there's this constraints page which is very important. So basically what this is you know when you manufacture PCB, right, it's a mechanical thing, right? Like they need to manufacture it using a machine. So as with machines, they have manufacturing limitations. So how you find manufacturing limitations is you go to the company that you want you to manufacture the PCB, in this case GLC PCB, right? You search manufacturing capabilities. Go search, it should come up top page. It's a page on capabilities. This is where they tell you the minimum size of things, the maximum size of things, what you can do, what you cannot do, how many layers you can have, your drills, how big it can be, how small it can be, that kind of stuff. Obviously, that page is full of information, so for simplicity, I have here, you can just copy this image. The values just copy this image, so the slides are available on these links as well. So 0.152, 0.152. That's what I'm going to do. 0.152. 0.152, 0.15.
So this gonna take a small break.
0.6. I'm going over so.
No, that's fine. That's fine. We've been till 5 p.m. So yeah.
Yeah. 0.5, 0.3, 0.254. Okay, so like these limits that you just entered, right, they are important because when you draw the PCB, right, KiCad will follow these rules, these values, to make sure that you do not violate these constraints. But whatever values GLC PCB tells you to, or whatever manufacturer tells you to, right, try not to go near the value, because usually for some limits, right, if you get the closer you go to, right, the more expensive your PCB costs, because like yeah, it's reaching their limitation. So these values are like, there's like a good buffer to them, so that it's not so demanding for them.
Yeah, you have to hold up this slide and then later we take a small break. Like a toilet break.
Sure. Okay, then you can see here, once you're done with constraints, under predefined sizes on this tab, right, you can see there's tracks, vias, differential pairs. What these are is basically, later when you draw the PCB, right, you can choose like a bunch of sizes of like your wires, your trace size, your hole size, that kind of stuff. And there's this drop down that you can use to select. You can see here, right now there's nothing. Why? Because we haven't configured how to configure this window. So for simplicity, let's just go with tracks 0.5 millimeter. Then vias, you can go like diameter of 1 with a hole 0.5. That's it. Differential pairs we won't be touching today, so it's fine. Then also there's under net classes over here. There is you can also change your default values over here. So just now the values that you change are the drop down values for you to easily use. This one is the default values of everything. So track width, I'll use 0.5 also. Via, I'll use 1 with like 0.5. Yeah, so these are the setups that I like to use. As you work on more PCB projects, you have your own like favorite thing, your own favorite like values. So I press OK, and now I am set up to basically start laying out my components. You want to break here?
Yeah, let's break it. I'll pull up the configuration, the number, so if people haven't finished typing.
Okay, so I'll be leaving this slide here. We'll be going for a short water/toilet break for
420?
Yeah, for like 5 minutes until 4:20. If you have any questions, you can just approach us. You want the slides, is over on this URL at the bottom. You want the final done project, is also here.
The record say 4 for long.
Huh? Oh wait, I haven't public. My bad.
Is this Firefox?
Oh. God damn it.
Leave your foot. Yeah.
Okay, try accessing the repo again. Should be public now. Apologies. Yes.
My God.
So the repo link again is the second link over here.
So, step out.
My throat is so. You need to know. You need to want to do PCB hardware.
That's true. That's true.
Not now, later, after this. Yeah. You stay with me. Terrence, are you free after 5? Yeah, okay, so someone wants to verify the PCB design. Okay, great, we have 2 people. Yeah. It's a no guarantees attached.
It's okay, children in my grade.
Cannot eat here. Cannot eat here.
It's okay, I'm leaving.
That's even worse.
You want a cookie break now? Or?
Nope. No lah, cookie break, they all need to go out.
Yeah, they'll probably sleep. How much do you have left?
Designing the PCB, honestly not a lot lah. Not a lot lah, should be pretty straightforward.
Is the camera coming from? Oh, it's from your computer.
Okay. If not, I will continue on. Bye bye. Okay, so now you're here, right? So basically you have your blank PCB design sheet. So what you need to do, you already design it in the you already designed the schematics for it, right? So how do you import it here? Very easy. See this button, this both the schematic and the PCB button. You hover over it, it should say update PCB from schematic. Or you can press F8. Click on it, this window should pop up. It's a bunch of settings for you to configure. You can just leave it as is, honestly. Then you press update PCB. When you press update PCB, something should pop up over here, off the window. It's your components. You press close, right? Then your mouse will, like the components will be attached to your mouse. Then you just click it off to one side. So when you zoom in, again, same controls, right click, pan, scroll wheel, zoom. Zoom, zoom, zoom. You can see these are all your components. So the first step to PCB layout thing, right, is basically to verify that you even have the correct footprint. How to verify? See this button? It should show 3D viewer, or you can press Alt 3. Press on it. 3D viewer will show up. So this is a whole 3D renderer. So you can see this component is missing like the 3D what was it? The 3D step file, because it's yeah, by default it's not included, but we know it's a button. It means it's a shape of a button. So you can see here, this is the diode, which is LED, resistor, 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 USB. It looks correct. So very good, I can close it. If you see a warning that says malform, something, board outline malform, it's expected because you have not drawn the outline. So the second step after you verify that you got the correct components is basically to start having a general idea of which component goes where. So select the component, drag it around, press R to rotate. Same thing, R. Show something. Let's say I want the port to be on the left. So after my ports are on the left, right? So you can see, can you see like all these like random colored wires jumping all over the place? So these are what we call rat's nest. So rat's nest is basically something to help you to figure out which connection should go where. But the connections, the traces have not been drawn yet. These are just hints for you. So let's say I have this, right? So rotate. So right now my USB connector will be facing off the left. So when you connect and disconnect, the plug cable goes in from the left. Then afterwards, my button should go somewhere else, right? So one very pro tip, right, is that, right, if you got multiple screens, right? If you got multiple screens like this, right? Currently it's a bit cramped, but if you got multiple screens, you click on any component, you click on this USB component, right? It will highlight it in the schematic as well. So you click on this, you can see you highlight it here. So basically, a very good, this is very useful because you can tell, okay, so my USB must connect to a button, right? So I place the button next to a USB. Then what's next is a resistor, right? I click on this, you focus on the PCB window. So then I drag somewhere beside the button. Then what's after the resistor is the LED. So I again put it beside the LED, beside the resistor. Then it's ground. Ground is basically just we'll deal with it later. So you can see then the remaining two resistors are connected to the CC pins, right? So very easily, where are the CC pins? Zoom in here. These are the CC pins. You'll see you click on the pads, it will also like highlight on the schematic. Yeah, so these are all very helpful features. So obviously now you realize that, oh, I don't have like exactly a place for like my resistors, right? So very easy, I can just highlight everything, drag here, this one come here. Yeah, so you see when I drag over this, the rat's nest line will show me kind of where I want my components to be. So here is a good place. Then here is a good place. Then this one, can you see that the rat's nest line is like going from here to here to here, which is like a bit weird. I kind of want, because of how I explained how USB-C is, right? Remember there are two pads that are the same thing, then you connect them together. So this pad over here, we also need to connect to here. These are all connected. So obviously the most ideal layout that you have is basically to just rotate it. Oops, wrong side. Rotate it like that. Because then your connected pads are these.
Can you just bridge the two pads on the USB-C connector itself?
Yes, that's what we're going to do later. Yeah. So so right now we're just doing placement. So you can kind of get a feel of where the components are going to go. So these and these are pad 1 of the button. This and this is pad 2 of the buttons. So pad 2 of the buttons, you can see, wow, now it wants to connect to this resistor, right? Because the next, after the buttons is a resistor. You can see the resistor, let's say I just place it somewhere here. Then after the resistor is the diode, which is the LED. You can see the diode is, let's say, somewhere here. You can see, so this connects to this connects to this goes to ground. Makes sense, right? So you can kind of visualize like the wires in your head already. So a very important thing when doing PCB layouting is basically putting the components in the right place first before you start drawing the wires. Because if you don't, right, the moment you start drawing wires, right, and then you realize that something's off about the placement, right, you not only need to move the components to the right spot, your wires will also need to have to delete the correct wires, then make sure don't delete the wrong wires, then like redraw the wires. Then when we redraw wires, you'll be like, oh, but the PCB board is too crowded at that spot now. So now I need to move all other elements out of the way. So yeah, to avoid the headache, just have good layout placements first. So now you do this. When you go with the 3D view, you should be able to see your layout should be something like this. So what's one very obvious flaw that you see? The letters are like covered, right? So these letters, remember, are what we call silk screen. To choose the active layer, right? To choose the silk screen layer, you can see over on here, there's front silk screen, back silk screen. Click on the front silk screen. Why? Because these are on the front. If you don't know which layer they're on, look at the colors. Yeah. So you choose front silk screen. Let's say I want this, I want to move it out of the way. Then this one, I don't like it to be at the side, right? Because why is it at the side? So I can just move here, then rotate it. Press R to rotate also. Then put it here. And this one, let's say I move here. This one, I move here. This one, I can move like here. Makes much more sense, right? So when you look at the 3D viewer again, you can see now nothing is like overlapping. Makes much more sense and it's a lot more neater. Okay? Can, right? Save your project. Then once you're done with this, right, your next step is basically to then draw your bounding box. So what we call the bounding box is basically the shape of your PCB. So the shape of a PCB, you define it via edge cuts layer. So you go to edge cuts, you click on it, like you click on like the space here, and then you draw a shape because your cut should be in the form of a shape. So what shape? Must be a rectangle because it feels like a rectangle, right? It feels like a rectangle, so you draw a rectangle. How you draw a rectangle? Over here, there's draw rectangles. Draw rectangles, click on it. How do you draw a rectangle? Click once and then it should show. You click once, and then it should show this outline over here. then you show here. So I'm not happy with this placement, right? So what I can do is I press escape to escape out of drawing another rectangle, and then I use the handles to adjust the position of stuff. Can anyone got any issues so far? How do I know that I draw the edge cuts layer correctly? Very easy, save it and then go 3D view again. Now the warning should be gone because now you have a correct outline of the board. Remember this 3D view, you can move around also, you can flip to the back, you can do whatever you want. Can, right? So finally, I draw the wires. Wires, very easy to draw. See this thing over here? This is called route single track. You press X or you press this button. You click on it, then I can start drawing the wire. What size I want to use, what size I want, I select here. This is use default, which we configured just now. This is use 0.5. I just use the default because I already configured correctly my defaults. So I start with this because you can see like all these are very easy connections. I can start with it. So this goes to here. Just click on the pads and then it will go to the pad. It will snap. So you can see when my mouse is going around, you snap to the pads when this mode, the draw track mode is active. Click here, click here. Ground, we leave it first. We don't connect ground first. Then what's next? You can see here, this goes here. This goes here. Yeah, so you can see when you are laid out correctly, right, things are very easy to wire up because the red snaps makes sense. Then this, I can, okay, so internally, right, in the button, right, if you look at the documentation, right, this and these are internally wired together already. This and these are internally wired together because they are same pad. That's why they're same pad numbers. But I can also wire them up if I choose to. I mean, it makes no difference. So for this, for example, this I can wire to this, then these are wired to this. Why? Because the button, the next thing that is connected to a button is the resistor, which is this. So after the resistor is the diode, which is the LED. So I click. So now you may be wondering, like, while I'm drawing the traces, right, which layer am I actually drawing it on? It's red in color, so it's FCU, so front copper. If I want back copper, I click on back copper. Then when I draw, right, it will be blue. So it will be behind. It will be on the second layer. That's why you can cross over, for example, something like that. Once you're done, you double click. You can see something like that. Yeah. You undo, redo, Control Z, Control Y, same thing lah. Can everyone got to this step so far, right? So now I can see all my connections are basically wired up together. So these and these are connected because it goes through here. So the ground is what's left that's unconnected. So how do I connect ground? Usually, right, for ground, right, we do a ground pour. Ground pour, what does it mean? It means you fill the entire board with ground. Why? Because it's just more efficient that way. It reduces like interference, capacitance, that kind of stuff. Yeah. So very easily, how do I do a pour? I can just go to these two called this one, the blue. What's that shape? The blue rectangular stuff called draw field zone. Click on it. I can click on. I want to pour over the whole board, right? So I click on the start of the board. If I click on it, this should come up. If you don't see this, if you see something like this, instead, right, it means you are drawing on a layer that's not copper. So you don't want this because you want, oh, sorry, wrong one. Sorry, I clicked on the wrong one. So if you see something like this, right, this. That means you are selecting something else other than copper, which is not what you want. So you need to select copper first. Then you select the draw rule areas. Then the copper rule areas will come up. So I want fill on the both front and back. So I select back. I want it filled with ground. So I choose the ground net. So zone name, I can give it anything. So I can choose, for example, GND field, so ground field, so that I know what it's referring to. So it's just a name I give myself so I can refer to it later. So everything else looks okay. Then when I press OK, right, my drawing tool now starts to draw the field. So where do I draw? I just cover the whole board. So it's like just drawing the rectangle, but this time I need to draw line by line. When I'm done with it, I end off by clicking on the same place. Then once I'm done, you should be able to see this hatchet line. Some of your KiCad settings might automatically fill it with a background fill rate, but if not, right, just press B on your keyboard, like B for, I don't know, B. Just press B to fill. Then when you press B to fill, right, you can see these shaded things taking over. Why? Because these are basically the ground zones. Field, ground, field. Yeah. Okay. So if it's too distracting for you, right, you can go over to objects and then your field shapes just lowered. Is it field shapes? Sorry, not field shapes, zones. You can lower the opacity of it. Or you can just make it invisible. Yeah, because it annoys me sometimes also when it's like too high contrast. So now your next question would be like, well, how do I see like what's on the front, what's on the back, that kind of stuff, right? So very easily, you can actually either toggle each layer on and off, like between the F and Bs, like the front and backs, or you can use the preset here. Front layer shows the front layer. Back layer shows the back layer. This is just a rat's nest from the front layer. Yeah. Okay, so then now that we are done, we go back to all layers so that everything is shown again. Then our last issue is basically our ground connections that we haven't connected yet, right? So now we have a ground port, right? So most of the things should be connected. But I can see there's this here. Why? Because this ground is not. Because this ground field over here is floating. Can you see it's just an island by itself, on the front. Where is it? If you go front layer, can you see this ground field is just floating by itself? So this is usually not good because you want to ground all the grounds to one common ground. Yeah. How do you do that? Very easy. You put what we call vias everywhere. So via is this thing that connects. Remember, the via is the thing that connects the top and the bottom layer. So because your top is ground, your bottom is ground, just connect them together. So if you put enough connections, they should hopefully eventually all connect to the same ground. So I usually like to put quite a bit of vias because they reduce it's like good PCB practice, and also it gives me less trouble afterwards with like errors, which I will show you later. Let's say I put something like this. Okay, let's say I'm happy with it now, right? I press escape. So now with the vias on the top, right, the vias, by the nature of vias, right, they connect two layers, right? So the front layer will have via. When you put on the front layer, the back layer also will have. So when you go front, yeah, then when you go all layers here, you can see like this should be your final product. But are you satisfied with your final product? I don't know. Let's ask KiCad to see whether KiCad is satisfied with the final product. Meaning whether there are any wrong connections, whether there are any electrical violations. Yeah. So how you do that is via design rules checker. Click on this. It's the same thing as the one in the schematic. It's just that now this one is for PCB. So you click test for parity between PCB and schematic also. Click on this because this checks for any differences between your PCB and the schematic. I mean self-explanatory. Then you click run. Do a bit of run. Then if all is good, right, it should be all okay. No errors. This is good. If you have error, you have to review the error before you send. Because the errors that you make here are free. The errors that you make after you send your PCB is, I don't know, no amount of money can solve unless you buy another PCB. Yeah. So now that I'm satisfied with this, I can do like my last finishing touches. For example, just for information, right? I can also do, for example, things like when I'm wiring, right? Let's say I'm wiring this pad to like another layer. I can like also do a via. What's via? V. When you press V, right, you can have a veer and then it goes to the other layer. Yeah, this is just for your information. It's just that this project we didn't use it because this board is not complicated at all. Oops. You want to quit out of drawing the wires, press escape. You want to quit out of anything, just press escape. Yeah. So this should be your final board product. Save it. Go 3D viewer for one last final check. Look at it. Kind of looks okay. Kind of looks nothing wrong. You go horizontal like this. You can see the pipes here. These are the vias. Yeah. I look happy. It looks happy with this, so I will just save this and then I'll export it to JLC PCB for manufacturing. How do I export it? There are various ways. The way that I'll be using is via via an extension, via a plugin. So if I go plugins, right, I'm using this. Oh no, we need to look. Okay, I'm using this KitKat JLC PCB tools plugin. So where is it available at? It's available at this GitHub repo. You don't want to type in the URL. Is it here? No, I didn't put the link here. Oh no. Okay. Yeah, if you search for Boney KitKat JLC PCB tools, it should come up. Then you go down to the installation instructions. You can just follow the installation instruction here. So you copy this. Yeah, so you copy this string into the open package directory. Is it installed from before? No. It's managed from repositories again. Oh, here, okay. You go to repositories, you go to manage. Manage, then this will come up. Then you add this repository to the URL. Then when you add it, right, you refresh, you should be able to see this plugin come up. Then you install the plugin. So again, the repository is over here. Then you look at the installation instructions. Can? Okay, if it's alright, okay, then you should be able to see this icon. You quit out of like the.
Can you go to the repo link again?
This link. Yeah, so we're using this plugin because it's a very famous and common plugin to use for JLC PCB. Yeah. So this plugin ensures basically you generate the correct file format for JLC PCB. Then how you install is you just copy this URL. You copy this URL into plugins and content manager, manage. Then you paste it here.
So what's the plugin content manager?
Your project home, your home here, under here. Can anybody got issues? Can?
As a general question,
Yeah.
Is it cheaper to put parts on only one side?
Terrence, is it cheaper to put parts only one side?
Yes. I think for small batches.
Is it like a significant price difference or just like
On the I don't remember the exact number, but I think it's not. But if you scale up large enough, your cost becomes
Thank you.
Okay, if you are done, right, then you close out of this. You close out of this, save it first, then you close out of this. Then when you go back to PCB editor, you should be able to see a new icon here. The GLC PCB, is it? Something like the GLC PCB icon. You click on it. If all is well, you see the LCHC number should already be auto-filled in. Why? Because remember just now when we went to the schematics, and then we filled in the... Hey, where did you go? You went somewhere. Yeah, we filled in the component parts here, which I have no idea where it went now. Oh, that's crazy.
Never show column.
Is it not show column? Where? Oh! Okay, yeah. Now I show the column, right? Yeah, see, it's here. Yeah, so these are the numbers that it got from. Thank you. So yeah, over here you can see, you want to see the stock, right? You just click the download button here. The download button here will download the entire inventory from JLC PCB. Yeah. There's a lot more functionality to this plugin, but I won't walk you through. You can just play around with it if you want. But the important thing is, you see the LCSC number populated here for all your components. This means that JLC PCB can basically assemble the components on your PCB for you, if you choose the option. So from here, if you want, you choose 2-layer, because we are building a 2-layer board, right? Top and bottom. Then, your final thing to do is to click generate. You say order serial number, placeholder not present, whatever, just okay. So it will be done when you see this finish generating BOM file. So they say finish generating BOM file, right? But where did they generate to? Very easy. It generated it to here, a folder called GLC PCB. Then you can see your Gerber files, your production files, whatever. So these are the files that you need to order from GLC PCB. This is GLC PCB specific steps. So if you want to use other PCB manufacturers, adapt according to your needs. Okay, so how do I order from GLC PCB? Very easy. Remember this site where we were searching for? Go back to the home page. See this big order now button on the top right, on the nav bar. Yes. Click order now. Then you'll be directed to here. Oh, that's crazy. Okay, whatever. Then you can see this upload Gerber file, add Gerber file. So very easy, just click add Gerber file. Where do you go? You go to your project. Oh, this one. Your project, your GLC PCB, your production files. Then your Gerber blah 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 .zip. Click on this. You can see processing Gerber. Then uploading your files. Blah 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 blah. Wait for it to upload. You process. Let it just let it process. Then once they are done, if it ever been done. Okay, yeah. So once it's done, you can see this. So make sure you check. This looks correct, right? I mean, it looks like our board lah. So it definitely looks correct. So then you can choose all your settings here. FR4 is the material that we are using because it's the most default, most basic material. 2 layers, correct. Dimensions are auto-filled, so don't have to touch. This is where you choose a PCB quantity. You can see for 5 PCBs of these, right, it's very cheap. It's just 220. Excluding shipping.
I keep it down to like, including shipping, about 5 cents.
Oh, really? That's cheap. Okay.
You just don't ask them to assemble.
Yeah, okay, you can see here, shipping estimate 11.49. Not that bad lah. So you can go all the way to like 70K if you so choose to. This one is product type, just suit the industrial, commercial, consumer. Choose this if you want edge rounding, choose no if you don't want edge rounding. There's only one design in this file. It's a single PCB that we uploaded. PCB thickness can leave it as it is. 1.6 is the standard size. Then PCB color, this way you can choose your color. Let's say I don't want the default green, I want purple. You can pick here purple. Then it will be purple. Or you can click yellow if you really want yellow. Oh, it looks ugly. Okay, whatever. Silk screen. Yeah, then choose the silk screen color. Your material type. These are the different materials of like the substrate. Yeah, so FR4 is the material that we are going with, so we just choose here. Your surface finish, right, is basically your pads. What kind of pad coating, in a sense. You can think of it as a pad coating that you want. So there's with lead, no lead, and anic. Anic is the pads appear golden, which is the coolest but also the most expensive. So if you want to go lead free, you can see like each option like will like adjust, you will change your cost. So lead free, it's like 330, not that much because we are just like having 5 PCBs. Anic will be like 18. Oh, okay, yeah. Truly worth its weight in gold. Okay, yeah, so if you go lead free, then this is like, you can see all these like other options they can pick. I won't be going through all of it. It's just like, you can read, if you want to know what it is, just hover over this like question mark, it will tell you lah. This is where you can put your remarks or something. This is very important. If you want GLC PCB to assemble your components on after they manufacture the PCB, right, choose this option. Select this. If you don't select this, it will come with a bare PCB. So you can choose which side you want to assemble. Bottom we got nothing, so we just assemble top side. Then we can assemble economic top side, blah 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 blah. Blah 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 blah. Yeah, all these are not important for us. Okay, once you're done, right, you click next. Next. Then you come to this page. You'll be like, wow, confirm that your PCB looks like this. Then you'll be like, yes, my PCB looks like this. Then you're like, wow, bill of materials. Then I have to add the bill of materials to tell GLC PCB what components go on which pad. So, not the backup. Under the GLC PCB folder that they generated, right? Can you see these 2 CSV files? So these are what you need to upload. BOM goes to BOM. CPL goes to CPL. Then you press process. Then you can see this is what they, after they process the 2 CSV file, right? You can see all your components that you've chosen here for whichever like components that you have on the PCB. So check, make sure all these are correct. If it's not correct, you can edit it here, or you edit in KiCad, re-export, re-upload. Yeah, both works. Once I'm happy, I make sure I want to select everything for GLC PCB to put everything in. Then I click next. Okay. Then there should be a preview here of like where everything goes, which you should check on your browser. It should work. Mine doesn't for some reason because I disabled WebGL. But I look at this, it looks correct lah. It looks somewhat correct, so I'm just going to go next. But don't do this I'm doing this because I'm not ordering If you're ordering, yeah, it's your money So make sure everything's correct. So in the last code and order, right, you can see this. The total price is over here, the weight is over here, all the details that you want is over here. I got a special offer because it's my first time doing PCBA, which is assembly of components. Then once you're done, you can have a product description if you want. If not, you press save to cart. Or oh wow, you have to have. If I put HS,
I think you have to click the drop down. Is it because you're WebGL?
God damn. Okay, why? Okay, but if you click save to cart, it should save it to cart, and then you'll be in your cart, and then you can order. Then this will be your final price. So as you can see, it's actually not that expensive. PCB manufacturing costs have like come down quite a lot. This is including shipping.
How much is it?
1769 for 5. Yeah. Sorry?
Includes shipping? Are you sure?
Yes, include shipping.
Where's the shipping price written?
It was before, where is it? Eh? Is it including shipping?
Maybe not. But shipping is from China, so right? So it's like a few dollars.
Oh
I hope.
no, that's what you think.
No?
No.
It's DHL? But isn't it like shipping via sea? It's like
Okay,
30
my
days
thing
to-
doesn't work, so if someone manages to get it to work,
Wait, what's your... Do you have it open? Because last time I printed, it was quite cheap. It was like $5, like 25 total, including shipping, for 5 pieces.
okay,
5
no,
PCBs.
it's not here.
You know, 5 or 10.
Okay, but yeah, if you order, okay, I don't know if it's including or excluding shipping, but even then, it's like not like $100 or something. So PCB prices have come down by a lot. So yes, you can print away if you so desire.
Surely.
And once you're done, make sure save everything, don't lose your work. And ta-da, you're done. Yay! Look, it's a PCB board. Wow, that's crazy. So obviously, this is your first PCB, right? What's next? So obviously there's a lot of things that are next. Firstly, you can make more sophisticated designs. If you realize like we didn't even touch any like MCUs, any like components, like any of those like integrated components with like those small little pins that have to wire together. Yeah, so you can try out if you have projects that you want to work on, you can try designing them in PCB for practice as well. Then you can see how it turns out. Yeah, so it's a skill. PCB design is a skill of like making the PCB look nice, work efficiently, Yeah. You can also like do more advanced electronic concept stuff like RF design, like radio frequency design, or like high-speed PCBs. So like you can have like, for example, your DDR memory. You can like try to make a PCB for that to like read like manage your DDR memory, that kind of stuff. But that one will involve high-speed design because your memory speeds are insanely fast. So you need to take into consideration your PCB design. So obviously the third thing over here, which I've mentioned just now, is that you can also learn to design your custom schematic symbols, which is your circuit symbols, and your PCB footprint, which is the shape on of the thing on your PCB. So those are very easy to make. You can learn it by yourself. It's just drawing some shapes on the correct layers. That's pretty much it. Yeah, you can also simulate a schematic with what we call NG-Spice built into KiCad. So it's a circuit simulator where you can like try to make try out different things on your circuit before you send it for production to make sure everything works correctly. For example, make sure your 5 volts when it passes through a resistor, passes through a capacitor, goes through this IC component, go through the SC component. Make sure you are still receiving the correct signal, or like make sure the signal's not too noisy, don't have weird like spikes or like dips, that kind of stuff. Yeah, but yeah, so this under simulation. And obviously there's a lot more things you can learn for KiCad, but like as with everything, it just comes down to practice and projects. Yeah. I mean, you don't need to have a reason to make PCBs. I can just do it for fun. Yeah. Obviously, further resources. Today's workshop didn't really require any engineering knowledge or principles, in the sense that you don't need to know anything other than Ohm's law. Even if you don't know Ohm's law, just use the online calculator. Yeah. So when you go to advanced electronics like RF, that kind of stuff, you start to need to know all your equations and figure out the values of, like, for example, your capacitors, your resistors, your that kind of stuff, Yeah, so you want to brush out that, this is a very good site. It's called Basic Electronics Tutorials. Yeah, you click on it, they'll start explaining from the very basics all the way to like the formulas, the complex formulas that you may need. The second link over here is the KiCad documentation. So like if you have any issues in KiCad, you don't know how to use KiCad, you don't know what this button does, what that button does, just go this documentation. It's the manual for KiCad. It's like your man page, but for KiCad, but on website form. Yeah. If not, yeah, thanks. Feel free to ask us anything.
I have a question.
Yes.
Can we see the PCBs for the TriCAD for this?
Oh, okay. So Hack&Roll just concluded, right? So I know some people are very curious about the PCBs. We have actually open sourced it. It's on GitHub, NUS Hackers GitHub, or I can open it for you here if I find it. NUS Hackers H&R Hack&Roll hardware batch PCB. Yeah, so this is the complete PCB batch for Hack&Roll. So obviously very complicated. Again, you can separate it by layers. Front layer, this is the front layer. Everything that goes on the front. Red is copper traces and copper fields. You can see all these holes are like those true hole components. This is a hole for lanyard. These are the 10 LEDs. Not too dissimilar from what you actually saw just now. It's just that this is the 0805 size. The one that we used was it 0603 or something, 0402, can't remember. Yeah, then see this is a connector. These are the buttons. That is actually the same as what we used just now. Yeah. Then if you want to look over at the back layer, you can see, then these are the exposed copper pads to connect to other boards. These are the resistors. This is the I/O expander, which is basically just a chip that you connect to another chip. Yeah. These are resistors as well. So you can tell it's resistor because it's R for resistor. Then this is the USB-C. This is the battery. No, this is the battery plug. This is the battery. Then these are all the wires. You can see the wires are of different sizes because of how small the pads are for some of them. So you need to adapt your wire size. Yeah. Then this is the microcontroller chip itself. This is the ESP chip. Then this is the NFC coil. This is the NFC component itself. So obviously, you can also view it in like 3D view, which it's green here. Okay, because I haven't edited the colors, but yeah, I can see this is how it look like with like the 3D files are missing here because we didn't edit. Cause yeah, we didn't exactly make the effort to find it also. Yes, so this is like this board minus the components over here is basically what you've learned today on how to do traces, except for like those things like, your USB can have data lines, right? So that one you need differential pairs, but you can learn it by yourself. It's very easy. Basically, long story short, two traces of wires that need the same length. That's it. Yeah. So if you want a board to take home for keepsake without all these components assembled, there are some over here. You can come and take it. Before you leave, we have cookies for you at the back. Go and take it and eat it as well, but don't eat it here because there's no eating in Makers. Yeah, or else if you have any questions, you can come forward to ask me or Yadunan.